So this is Tuesday. You're titling your notes Tuesday, March 12th, period 3. And then the title of your notes is going to be Balancing Equations. So the first thing we want to do is we want to diagram an equation. All right, so that's what we're going to do first. So we have H plus O, and then we have the double arrow, and we have H2O. So let's diagram this. What do all of these things mean? Well, first, we have reactants. We have products. So the hydrogen and the oxygen are reacting, and then they are producing, which this arrow, we call this yields. So the reason we say yields instead of equals is because equals is stagnant, like 2 plus 2 equals 4. That's it, we're done. But in this case, it's a yield because it moves, it's moving. And remember, it's even doing that equilibrium dance that I talked about, right? And the reason it is because the reversible arrows. So this one is a reversible reaction. Now, when we look at this equation, what we see is that this here, this 2, is called a subscript. And it tells us how many hydrogens there are, right? And there's a 2, so 2 hydrogens. But there's no subscript here after the oxygen. What should that be? Well, that's 1, and we call it an implied 1. This is called a 1 implied. So in other words, in water, we have 2 hydrogen atoms and 1 oxygen atom. And you guys know this because you've seen this. Right? With 2 hydrogen atoms and 1 oxygen atom. So that little subscript tells you how many atoms there are of the element to the left. So according to this, I see 1 hydrogen plus 1 oxygen yields 2 hydrogens and 1 oxygen. So did that second hydrogen just like come out of the air? Well, it can't. It can't just come out of the air. And the reason is because of the law of conservation of matter, which I know that you know about. The law of conservation of mass and matter. Basically, what it says is what you start with you must end with. Super easy. In other words, matter it cannot be created or destroyed in a chemical reaction, which is the way you may have heard it. All right? Now, if that's true, we have a problem. Because I have 1 hydrogen and 1 oxygen, and then over here I have 2 hydrogen and oxygens. 2 hydrogens and 1 oxygen. Now, I could just add another 2 here, sure, except that, and then double these. I don't know what to do. I could just take this 2 away, except that then it would not be water. All right? So let's take a look of how this works. Why is this happening, and what are we going to do about it? All right? So first, we need to talk about diatomic elements. Okay? Diatomic, di meaning, what does di mean? 2, excellent, 2. So these are elements that cannot be alone And so they will even be with one of their own. They will always be bonded to something. Because these elements must be bonded to something, it means that if I have a tank of oxygen, of which oxygen is one of the diatomic elements, inside that tank is not like a bunch of oxygen atoms floating around. Inside that tank is a bunch of O2s floating around because it's bonded with another oxygen. Oxygen must be bonded with something. And if there's nothing else there but another oxygen, they will bond together. Now, there are 7 of these on the periodic table. There are 2 ways to remember them. The first way I had never heard of until actually I came up to Connecticut, so I think it's regional, which is kind of funny, right? So I get up here and everybody says, oh, it is Brinkelhoff. These are the 7 diatomic elements on the periodic table. Bromine, which is shown as Br2, because it must bond with something, so it bonds with itself, right? Iodine, which would be I2. Nitrogen, which would be N2. Chlorine, which would be Cl2. Hydrogen, which would be H2. Oxygen, which would be O2. And fluorine, which would be F2. So anytime these elements are written into an equation by themselves, they always have to have a 2 because there's 2 of them together. They're never by themselves, okay? The second way to remember this, so the first way is Brinkelhoff. The second way is using the periodic table. You start with number 7. So number 7 is nitrogen. You make a 7. So, starting with nitrogen, I would have nitrogen, oxygen, fluorine, and then to make a 7, I'm going to go down. Chlorine, bromine, iodine. That's 6. Plus 1, number 1, which is hydrogen. So that's 7. So start with number 7, make a 7 plus 1. So that's another way to learn them. Now, do you have to learn them? No, you have a summary sheet. You have to learn them when you're in honors, but not now, but yeah. Mm-hmm. If oxygen has to have a 2, why doesn't it have one in H2O? It's bonded to the hydrogens, right? So it's not by itself. Does that make sense? It's in like a little threesome, so it's good. But if it's by itself, then it can't be. All right? That's a great question. All right, so now let's look at the equation we were looking at before. So the equation that we started with, remember, was H plus O yields, reversibly, H2O. So the first thing we notice is that the hydrogen and the oxygen are diatomic. So I've got to put 2's there, okay? And that's why when you see this equation, you always see H2 and O2, because they can't be by themselves. Now, the next thing is, did that solve the law of conservation problem? It did not. It didn't, because I have 2 hydrogens here and 2 hydrogens here, and I have 2 oxygens here and 1 here. So something happened. So this is like a recipe. If you had a recipe that needed 4 eggs and you only had 2, you wouldn't go ahead and make the recipe with with only 2 eggs. That would ruin it, right? So instead, what you do is you divide the recipe in half. And now it's all good. You're not using as much as the other ingredients, but you're okay with just the 2 eggs. Everybody with me? Because I just split it in half. I just split the recipe in half. So that's what we're going to do here. The first thing we're going to do what's called balancing equations. Now, also, the other thing is, okay, never mind. All right. So we're going to balance the equation. The first thing we're going to do is we're going to run tallies on how many of each element we have. So on the reactant side, I have hydrogen and oxygen. I have 2 hydrogens and 2 oxygens. Now I go to my product side. I also have hydrogen and oxygen. But when I run my tallies on the product side, I have 2 hydrogens and 1 oxygen. Now, granted, I could just put a 2 here. No, you cannot do that. Here's why. H2O2 is hydrogen peroxide. So therefore, it is not water. So if I change the subscripts, I change the compound. All right? So you can never change the subscripts. Never change subscripts. The only thing that you're allowed to do to balance this equation is you can put coefficients in front and multiply it through. Just like in math, all right? If you have 2x or 4x, the 4 is a coefficient, and it means that you have 4 x's. So you can put a coefficient in front and multiply it through. So this is how we do this, all right? First, I look for what is not balanced, my oxygens. I can only put a coefficient in front, so I put a 2 here, and when I do, I now have 4 hydrogens, 2 times 2, and I have 2 oxygens, 2 times 1. Now I look, am I balanced? No, I am not balanced. The reason I'm not balanced is because here I have 2 hydrogens, and here I have 4 hydrogens. I need 2 on each side, or 4 on each side, or 8 on each side, whatever, but it has to be the same. So I'm going to put a 2 here. When I do that, that changes my hydrogens to 4, but it does not affect my oxygens. All right? So now I have 4 hydrogens and 2 oxygens in the reactants and in the products. I am now balanced. I'd like to be clear about something. The answer to this question is this. That box. This is work. Just the box is the answer. 2 hydrogens plus oxygen yields 2 waters. You also may see the answer like this, 2, 1, 2, which is 2, 1, 2. So we've taken the equation away and just given you the coefficients. It does not really matter which one you give to me, but on a test, if it were multiple choice, you could see this. It would say, like, balance this equation, and then you would see this. So when you're done, you just look at your coefficients. Note, there is no 1 here because it is implied. You can put it there if you want, although standard in chemistry is that it is not there. And since it is not there, but we do need the placeholder, we do put it here. Okay? All right, let's try another one, okay? You're going to do lots of these today. And I have a worksheet with 50 more of them for next class, so, all right? Okay, here we go. Here's the next equation. There it is, okay. All right, sodium plus chlorine, which is diatomic, yields sodium chloride. The first thing that we do is run our tallies. Now I know that you might right away already know what to do, but here's the problem. I am giving you very simple ones because why would I start with a hard one? First we want to learn it with simple ones, then we want to progress to the hard ones. All right, so first I'm going to run my tallies, so you want to make sure that you know how to do your tallies. Because when it gets harder, even the tallies are going to be more complicated. Okay, now I'm going to look what is balanced and what isn't balanced. Anybody? Yeah, Ethan. Chlorine. Right, the chlorine is not balanced. So the sodium is balanced, 1 and 1. The chlorine is not, 2 and 1. So I need to solve the chlorine problem. I'm going to put a 2 here. And when I do that, I now have 2 sodiums and 2 chlorines. First, I put the coefficient in, and then I redo my tallies. Okay, so how am I doing? Am I balanced? Eliza, am I balanced? No, I'm not. What's not balanced? The sodiums. Good, the sodiums. So I have 1 here, good job, and 2 here. So now I need to balance the sodiums. I put a 2 here, and I immediately change my tallies. Maddie, am I balanced? Yeah. I am balanced. Good job. I am balanced. So I'm going to box this because this is my answer. And then my answer also could be this. Okay? All right, let's try another one. The next 2 that we do, each one of them, we're going to learn a technique. Like they're tricks that make it easier. Okay, here we go. Aluminum plus O2 yields aluminum oxide. What is my first step? The first thing I'm going to do. Jackson, what's the first thing I'm going to do?
Look at all, like how many of each element.
Excellent. I'm going to run my tallies. Let's do that. Good job, Jackson. All right. 1, oxygen. 2. I like to put them in the same order so that when I'm looking at like 2, 4, 3 on one side, I know I need to see 2, 4, 3 on the other side. But they don't have to be. I could put oxygen first here and then aluminum. Wouldn't make any difference at all. Okay. So first, everything is unbalanced. But one of the things that I see is 2 times 3 equals 6. I have a 3 here and a 2 here. So I've got to go to my least common multiple, which is 6. All right, because there's no way I can make a 2 and a 3 match unless I do that, right? So I'm going to put a 2 here, and then I'm going to immediately change my tallies. How many aluminums do I have now? 4. Excellent. How many oxygens? 6. Okay, good. Good. Now, where do I go from here? I was supposed to make the 2 and the 3 match. So I'm going to put a 3 here. That's going to give me 6 oxygens. It does not affect the aluminum. Okay? All right. What's left? The aluminum. What am I going to do, Kaylee? I'm going to put a 4 in front of the aluminum. Good job. 4 aluminums, 6 oxygens. I am balanced. The tip that we learned here, so I'm just going to put a box around here. And then I'm going to write in my answer, 432. 4, 3, 2. That is my answer also. Also, not in addition to, you don't have to have them both, just one is fine. And so the tip we learned here is to go to the least common multiple. Okay? All right. The next problem is going to be a combustion. Now, C4H8 is what we call a hydrocarbon. It can have oxygen in it too, but it's a hydrocarbon. Hydrocarbons burn like in fire, and we call it combustion, and they have to have oxygen to do it. So we take the hydrocarbon and we're burning it in oxygen, and it's called combustion. Now, this is, by the way, butane gas that is in lighters and things like that. So butane gas in lighters, burning in the presence of oxygen. All right? And what is produced here every single time that you burn a hydrocarbon in the presence of oxygen in a combustion reaction, the products are CO2 plus H2O, carbon dioxide and water. Every time. So when we burn glucose, C6H12O6, in the presence of oxygen, you get carbon dioxide and water, and that is cellular respiration from biology. If I burn methane gas, which is a greenhouse gas, but it's flammable, if I burn it in the presence of oxygen, I get carbon dioxide and water. So that means that every time you have a combustion reaction, you have to balance it. Because you're always getting the same products, but you're starting with different amounts of things, right? So let's balance this. Now, the trick for combustion reactions, we always balance in alphabetical order. C, H, O. If you do this, they balance right through. If you choose to balance hydrogen first, you can still balance it, but it's not as easy. So you always balance them C, H, O. So here we go. The first thing I'm going to do is I'm going to run my tallies. Carbon, hydrogen, and oxygen. I have 4 carbons. And I have 8 hydrogens. And I have 2 oxygens. Is everybody okay, or are there any questions? Let's go to the other side. C, H, O. I have 1 carbon. I have 2 hydrogens. And I have 3 oxygens. 2 of them are here, and 1 of them is here. Now, I like to write this, 2 plus 1. But some people just want to write 3. So I, as the teacher, put 2 plus 1 equals 3. You can do whatever you want, but you need to record that in your products, you have 3 oxygens. All right? Okay, so now we're going to start to balance. Carbon first. I have 4 here, and I have 1 here. So what can I do, Miller? I can't add. We can only multiply.
By 4?
Yep, exactly. I can only multiply. All right? So 4, and then immediately I have to redo my tallies because I just changed stuff, right? So 4, now I have 4 carbons. I still have 2 hydrogens, so that's correct. But now my oxygens have changed. I have 4 times 2 is 8 plus 1. So now I have 9. Okay? Questions? All right, next one, ready? Hydrogens. I have 8 here and 2 here. What can I do? Sloan, what can I do? Multiply by 4. I can. Good job. So that gives me, I have to redo my tallies right away. 4 carbons, 8 hydrogens, 8 plus 4 equals 12 oxygens. Okay. Last, what am I going to do? Sean, what am I going to do last?
The other side.
Yep, so what's not balanced?
Oxygen.
The oxygen. And how am I going to balance that? Yep, I'm going to put a 6 in front. Good job. That gives me 12 here and 12 here. So I have 4, 8, 12, 4, 8, 12. This is my answer. And it also could be 1, 6, 4, 4. Questions? Okay, you ready to do some on your own? Where are we? 12:14. We have about 25 minutes, right? Okay, good. So, okay, we're going to start the worksheet with number 5. All right, and then I'm going to sort of like push you out of the nest. All right? Notice that the nitrogen and the hydrogen have 2's after them because they are diatomic. So where can I start? I'm going to start with the nitrogens. I'll start with the hydrogens, and that's because 2 times 3 is equal to 6. So I'm going to put a 2 here, which is going to change my nitrogens to 2 and my hydrogens to 6. I want to go over here and make my hydrogen 6, so I'm going to put a 3 here. Oh, I'm balanced. There it is. N2 plus 3H2 yields 2NH3. Questions? Okay, so what I'm going to suggest is that you do number 2, and then, excuse me, you can turn it over and do number 8. And what kind of a reaction is number 8? Number 8 is a combustion. It is a hydrocarbon with burning in the presence of oxygen. And so what order will we balance these in? Alphabetical. Carbon, hydrogen, and then oxygen. Okay? All right. So you're going to do number 2 and then number 8. And this is the end of the video. So I'm going to finish the video here.